Today I want to teach you about something that all game developers should know about. It's something that really confused me at first. I remember when I first heard people talking about it, I thought, wow, they're really smart and I have no idea what they're talking about. I wish I understood this stuff. And it took a few years, but now I get it and I can explain it to you. That thing is BigO notation. Now, if that scares you, don't worry. It's going to be interesting and it should apply to what you're doing as a game developer. We'll start with the definition. Then I want to go into some real-world examples that probably apply to games that you're working on or have worked on in the past. They definitely apply to things that I've done before. And then I want to end with a very Unity-specific issue around BigO notation that you're definitely going to want to know about and understand. If that sounds interesting, make sure that you hit the thumbs up button, subscribe, and drop a comment to let me know, and I'll keep making more videos like this. The first time I tried to learn BigO notation, I went to a definition like this. I think it might have been this exact Wikipedia one. And to be honest, it just confused me. You can read through it. Maybe it won't confuse you, but it totally confused me at the beginning. I didn't understand it. Didn't make a bit of sense. It says that the O stands for something that I'm not even sure how you pronounce, that it means the order of approximation. So let's ignore this completely and explain it like we're five. The BigO notation is essentially telling you the number of operations that something is going to run based on the number of inputs that are given into it. So I like to think of it as the BigO as the largest or biggest number of operations that a function or method or thing is going to perform. So think of BigO as the biggest number of operations. Now, it's important to know that it's not just like a set number of operations. It doesn't work like that at all. You don't put an O of like 10,000 and it's running 10,000 operations. Instead, what you're using the notation for is to show how it scales. So you want to show things whether they scale well, if you have one item versus a million items, or if it totally falls apart and scales terribly. And that's what this chart right here is showing. It's showing how a function or bit of code in your game perhaps performs based on the number of inputs. You can see that something that has an O of 1 is constant. It has a straight line all the way across, meaning that it doesn't matter how many enemies you have. If you write a method that finds the first one, it's always going to be just one operation because you always just need to look at that first enemy. But if you wrote a method that maybe looked for all of the enemies that have a sword or are within 10 meters, suddenly you're going to go up to that O of n. Not O of log n, you're going to go straight up to that O of n because you need to loop through each one of your enemies and then find the distance and see if it's far enough away. You might also want to find if it has a sword, and if that's far enough away. You would still be O of n though. It would not become an O of 2n because there's a hard rule in this BigO notation that you just delete or get rid of the constant. So if something is half of n squared or 3 times n squared or whatever, you drop those constants and just call it n squared, because as n grows, that double or half or whatever is going to disappear really quickly. Of course, it matters in real world when you're actually getting down to profiling things and you're right at the edge, but when you're looking at this as a formula, those numbers just disappear. So don't put them in there, and that's why you won't see them there. It kind of confused me at first, to be honest. Let's take a look at this chart again and see how you can get into the red though. That's where you have the n squared and even worse issues. These problems usually come from doing multiple loops, and it doesn't necessarily mean it's a loop within a loop, but often that's kind of what it is, like nested loops. A good example of this would be like all of your characters searching across all other characters to see which things are enemies that they should fight. Maybe you've got a list of all of your characters, and then in your update loop, each character looks at every other character to see if they're a viable option. In this scenario, your worst case would be that each enemy looks at each other enemy once, and then you have an n squared issue. So as it scales up, it becomes really bad. If you got 2 enemies, super simple, like each enemy looks once, you got 2. You got 4 enemies, it's starting to scale up a little bit, still relatively tiny. But then once you get to 100 or 1,000 enemies, things start to fall apart. You get to 1,000, all of a sudden you're doing 1,000,000 checks. And if you're doing that every frame, then you probably don't have a lot of time to do anything else in your game. So you've got to make sure that you're avoiding these n squared and worse issues. A lot of the times, what I'm usually looking for and refactoring down are the n squared problems first, looking for things that are being called very often. I'll talk about how to find those in just a minute. And then once I've resolved all of those, which I'll also explain real quickly in a moment, then I move down to the n issues and try to reduce those as well, if they're an issue, because sometimes they're not. And it's important to talk about that. So before we dive into details of how to track down these issues, let's talk about where it actually matters. And that's when you have a scenario where the method is going to take some large number of inputs. And so far in this video and in most of the examples that you see n as the number of inputs. That doesn't have to be the inputs though. It could be anything. It could be any letter that you want that represents the thing. It could be C for characters. It could be C and I for characters times items. You might have something that is C to the I in there where it's insanely crazy because it loops through each character and then for each item does something. You could theoretically end up like that, but most of the time what you're going to see is O of n, and usually again you're looking for things that are n squared or worse, where something is being done way too many times and there are some options or opportunities for optimization. So how do you find those problems? The first thing that you can do is open up your profiler. If you're in Unity, you just open up the profiler window and then sort by calls. If you look at things by call count, it'll often line up with the time. So you'll see that the things that are being called often have a large amount of time on them, but you'll see that things in there may show up in there like a couple thousand times. You might have something that got ran 10,000 times in a frame. And if you do, take a look at that. There's probably a really good opportunity for optimization. You're probably at an O of n squared issue there, or an O of n squared problem that you could maybe optimize. Now, how do you optimize these problems? That is, I think, the more important part. And a lot of it comes from profiling. You're going to need to track down exactly what the specific issue is. But once you've tracked down where the code is, or where the loop is, or the double loop, or whatever the thing is that needs to be sped up, there are a couple different things that you can do. The first is simply changing data structures. Here's a chart that shows the speed that it takes, or the time and complexity. I don't know exactly how to explain it. Maybe somebody can write it out in comments more detailed, but it tells you about how long it takes for each operation with a different type of collection. Adding things to the collection. So if you've got a collection that you need to add a lot to, you want to use one that has a O of 1 ideally, or an O of log n, which we'll talk about logs in just a moment. You want to use something that's smaller though. And if you're using a data source that you have to look things up from commonly, especially if you have to look them up by a specific key and you want to look through a list or a collection to find them, then you switch to something like a dictionary, which you've probably used. If you haven't used a dictionary, you're really missing out. You should definitely look into that and see the power of it. It'll really help with performance issues, and it definitely ties in very directly with what we're talking about here with BigO notation and performance. And hey, it'll make you sound smarter too when you're talking about it. So outside of swapping data structures, you can do a couple other things. You can kind of make your own data structures where you trade time complexity for space complexity. So you'll take some data, whatever that data is, maybe it's the selling price of items by all of the different vendors. And instead of just keeping that on the vendor and having everybody that needs to look at it somewhere, you can have those vendors publish all of their selling prices up to some data set, some maybe a dictionary of all of the items and the lowest priced vendors in there. They can just update in there, and then your buyers could go look at that bit of data instead of like querying each merchant to see who has the lowest price on an item. You do things like that to transfer the way that the data is used, or the way that the data is stored, so that it's easier to read, so that your read operations become like an O of 1 or an O of n instead of an O of n squared. And your write operation, maybe it becomes an O of n, but it could be an O of n squared, but you only do it once and it doesn't matter. That would be like you're writing or adding your merchant entry to the merchant so that it's not having to be looked up. And again, that could probably be done down to like an O of 1 or something faster. The last thing I want to talk about on the chart is this O of log n. If you've never seen it before, you don't really need to understand the underpinnings of how the log works. Just know that it essentially is going to reduce that number down dramatically. You could dive into the details. I'm sure somebody could give a really good explanation. I don't feel qualified to give it right now, but essentially think of it as the number number divided by 10. Or one person represented it pretty well as explain it like I'm 5 as the number of digits. So if it's 1,000, expect it to be about 3. If it's 10, expect it to be about 2. And if it's 10,000, expect it to be about 5. Again, approximations, just know that it means that it's going to be dramatically smaller. Those numbers, again, not completely accurate, but it means it's going to be dramatically smaller, but not quite 1. So it's close to O of 1, and it's what a lot of algorithms and a lot of data structures and data types strive for. So if you're really good at optimizing things, you'll get a lot of things down to O of log n, or even better sometimes. But that's what it means. And again, doesn't mean that it's something that you necessarily need to understand the details of. You'll probably forget them. I forget them all the time. But it's something to just know that kind of loosely what it means. Now, I want to talk about the Unity specific thing, because there's one thing that I think people miss a lot of the time with Unity when they're doing this, especially if you're not actively using the profiler. And that's the fact that your O of n squared issues happen all the time because of your update loop. If you're using something if you're doing anything in your update loop on an entity that you have multiple of, remember that you're already getting an O of n automatically. So if you have 100 characters and they all have an update and that thing does anything in it at all, or maybe it just moves them forward, that's an O of n update, because it happens once for every unit. Now, if in that thing you're looping through all of the other enemies or all of the other characters, you now automatically or instantly add an O of n squared. Big problem, right? This is where you can start to see issues. Or maybe you're looping through all of the items on every character. Again, you see this problem. And if you're doing a lot of game development, you probably run into these problems. And this is, again, just a way to explain those problems or to describe them to make you sound smart and make it easier to communicate them. So I hope this is somewhat helpful. The last thing that I want to mention is that there's also a little o, which shows the littlest amount of time in the same kind of notation. And there are two others that I don't want to talk about right now, but just know that there's a little bit more to it, but the main parts that matter we've covered right now. And I think hopefully you understand. Again, the most important part is to start to learn how to use that profiler so you can get better at it and find these problems without having to try to guess. It's good to be able to see them and understand them, but being able to actually find them with the profiler is really helpful. I got a video about that that's linked somewhere. Just go subscribe, hit thumbs up button, and ask in the comments. Somebody will probably share it if I forget to put it up there. All right, thanks again. Again, if you like this video, this kind of content, please hit the thumbs up button and let me know. It makes a big difference and makes me do more of these.